we're starting Unit 7. Unit 7 is looking at exponentials and logs, okay? So today we're going to talk about exponential functions, all right? And exponential functions, these are actually pretty cool, all right? These are graphs that have x in your exponent. So here, right? Your x is in the exponent, okay? And these guys are called exponential functions because the x is in the exponent. All right? And exponential functions, they always have a horizontal asymptote. Okay? All right. So I have y equals a times b to the x, right? What is my base for this exponent? What is the thing that the exponent is connected to? The b, right? That is your base, right? So this base, if that b is greater than 1, all right, if that number there is bigger than 1, or if your graph is going away from the asymptote, then we call that a growth, an exponential growth. But if that number b is greater than 0, less than 1, give me an example. What is a number that's greater than 0 but less than 1? 0.5. So like 1/2 or 1/3, right? I don't want to say just a fraction because what if I gave you a fraction like 4/3?
That's 1 point something.
Exactly, right? So, or if your graph is going towards the asymptote, then we call that a decay, an exponential decay. All right? So let's look at our first example, okay? We have y equals 2 to the x power. All right, so let's see here. First off, is this a growth or is it a decay? I'm going to go and look at my b. My b is 2. So that's a what?
A growth.
A growth. Why?
Because it's bigger than 2 is 1.
Good. It's greater than 1 because your b equals 2. Okay. So let's put this into the calculator. So I'm going to go to my calculator and I'm going to put in 2 to the x power. All right, so please make sure that you guys are putting this into the calculator. Everybody needs to try it. And then we're going to graph. So if you look at this function, right? First of all, the graph is, the right arm of it is going away from an asymptote, right? How do I know that there's an asymptote? Well, because on the left side, it looks like it's getting stuck. It can't go straight down. It's not going up. It's just going straight. That means it's stuck at an asymptote, okay? So, looks like I have an asymptote right here. All right? And then I'm going to go to second graph and go get my table. I already have my table up. Just make sure that you have the same table, okay? And then I'm going to fill in some numbers. So I'm going to put in negative 1.5, 0, 1, 1, 2, 2, 4, 3, 8. All right. So let's go and graph this. Negative 1.5. 0, 1, 1, 2, 2, 4, 3, 8. Right? Then I can see, you know, I mean, and I don't necessarily have to use all of these points, but it's good to get a better graph. All right? The way I can tell if it's a growth or a decay is that I need to look at the right arm of this graph. And the right arm is going away from the asymptote. That's how I know that this is a growth. Okay? Ready for the next one? All right. So let's look at this guy. Y equals 1/3 to the x power. Now, is this one a growth or a decay? Good. And it's a decay because my b, the base that the exponent is attached to, is what? Yeah, it's smaller than 1, but it's bigger than 0, right? Because b equals 1/3. Good. So let's put this into the calculator. So I'm going to put 1/3 in parentheses because I think it just looks better. To the x power, right? Now let's go to graph. You see that? You see how the right arm is going down towards an asymptote, right? And it looks like it's getting stuck. I mean, where does that asymptote look like it's at?
0.
0. Yeah, yeah. All right, so I'm going to draw a little dotted line at my asymptote. Because that is like you can't see it line that the graph can't cross. So let's see, we have -2, 9, -1, 3, 0, 1, 1.33, 2.11, and I mean you can do 3, but it doesn't matter. 0.04. Okay. -2, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's just getting closer and closer to 0, but it can't touch it, right? Just make sure that you don't cross through the asymptote. Yeah. What line? The graph? What do you mean? What do you mean line that approach? How else would you draw it? You got to plot your points and then make sure you just connect the dots. Right? Okay, so right arm is going towards the asymptote, right? It's not going away from it. It looks like it's going towards it. It wants to get stopped. That is a decay. Yeah? All right. So let's look at each of these. Example 3. Tell me if it's a growth or a decay. Which arm do we have to look at? Left or right?
Right.
Right arm. Okay. So if I look at this right arm, first of all, the asymptote, because this one keeps going that way, the asymptote seems to be here, right? So is this right arm going towards or away from the asymptote?
Away.
Yeah, it's going away. And on your notes, it says if it's going away, what is it?
It's a decay.
It's a growth.
No, I accidentally bind.
So then look at the next one. All right, seems like it's getting stuck there. There's my asymptote. If I look at the right arm, is that one going away or towards the asymptote? Towards. So which one is this? Decay. Good. All right, so of course, just like we did with every single function that we have learned this year, we need to talk about transformations, right? Okay, so we're going to start with my favorite. I like K. I like starting with K. So if we have plus K, how does that make the graph move?
Up.
Good. Up K. So if I have minus K,
Down.
down K. Good. What's going on?
She's saying that K.
Uh-oh. Listen, we're getting there. All right, so Yesley wants to talk about left and right. So how do we know which one's the left and which one's the right? Well, let's see. If I have x minus h, how does that move? Which one?
Right.
Right. Good. Remember, you got to think opposite from what you want, right? So if you have x plus h, left h, good. Thank you guys. Okay. And then I want to talk about A before I talk about B. So A. All right, so A has 3 different jobs that it can do. What if there's a negative in the front? Reflects or it flips it, right? Good. What if your A is greater than 1? Stretch. Because your number is bigger. But here, if your number A is greater than 0, but smaller than 1, less than 1, then it compresses. Good job. Questions so far? I mean, it's the same as we normally do with all those other functions, right? Same transformations. So now we're going to talk about B, because that is what's new when we talk about exponentials, right? You got to look for the base of your exponent, okay? So if we look at this B, if your B is greater than 1, then we said that that is a what? Growth. Grows because it's bigger. If your B, if your B is greater than 0 but less than 1, then that's a decay. Okay? All right, so the horizontal asymptote, I told you guys exponential functions have a horizontal asymptote, right? So first of all, horizontal asymptote is hoi. Do you agree?
Yeah.
So then the equation of a horizontal asymptote is going to be what? Y equals. Good. So y equals. And I'm going to tell you guys something. Getting the horizontal asymptote is super easy because all you have to do is look at your K number. I know. The K number tells you your horizontal asymptote. So good.
That's like 0.5 correct.
All right, so now here is here are two other things we need to talk about, the domain and the range. I want you to put a star next to the domain. Needs a star because for exponentials, this is always the case, okay? You see an exponential function, the domain is always all real numbers. And that's because there is no vertical asymptote to stop your graph from going all the way to the left or to the right, okay? Your graph can always go to the left. It can always go all the way to the right, right? So your range. Well, now your range is going to be different depending on where your graph is going, right? So since you have a horizontal asymptote, that means that your graph is going to get blocked somewhere going up and down, yeah? If you have an arrow going down, okay? One of the arrows in your graph is going down. Well, then your range is going to be going down negative infinity all the way to your horizontal asymptote. Which makes sense, right? Arrow going down, you're coming up from negative infinity. You have to stop at the horizontal asymptote.
Smells like negative infinity to
Good, yeah, so if you just want to put K instead of the HA, you could do that. And if you have an arrow going up, well then, that means that your graph starts at the horizontal asymptote, which is also K, like Mitchell said, and you go up to infinity. Right? And we'll practice kind of looking at the graph and figuring this out too. Any questions? All right. Okay, so let's look at our first graph. Okay. So what is the horizontal asymptote here? Guys, what is the K here? Is there one written?
0.
No, so a 0. Good. There isn't one written, so it's like you're saying plus 0. So your horizontal asymptote is what? X equals or Y equals?
Y equals 0.
Good. Y equals 0. Now, is this a growth or a decay? You see how my 2 is highlighted there? Good. I highlighted the 2 because that is the base that the exponent is attached to. Not the 4, it's the 2. And 2 is greater than 1, so this is a growth. And we can put B equals 2. That is why it is a growth. Okay? Now, what is always all real numbers? The domain or the range? Good. So we can write this one in now. So now for the range and the y-intercept, let's graph this, and then we can figure it out. So, you know, I have an asymptote at y equals 0, so I'm actually going to draw that in so that I have it. And then I'm going to put this into the calculator. So let's all go to y equals and when you put this in, put it in exactly the way you see it. 4 times 2 to the, guys, what's in the exponent? X minus 3. Both of those things are in the exponent, so please make sure you put that in parentheses. X minus 3. You want all of that to be included in the exponent.
Can we do plus 0 or not?
No. You don't have to write plus 0. Like, you wouldn't be wrong, but you're just doing more work. Okay? So if I graph this, I can take a look at it just so I get an idea of what my graph looks like. And look at the right arm of that graph. It's going away from the asymptote, right? So that's another, you know, check you know, like a check for understanding, yes, this is a verb, right? So I can go to second graph, and there's my table, okay? So I have my table copied over on the side. So I'm going to fill in some points here. So I can use negative 1.25, 0.5, 1, 1, 2, 2, 3, 4. I'm actually going to squeeze in this 4, 8 as well. Okay? And then let's graph this. Okay? Okay. So there's my graph. Now, let's talk about the range. Guys, do I have any arrows going straight down? No. So below my horizontal asymptote, does my graph even exist? No. So where does my graph start? It starts at the horizontal asymptote, which is at 0, and it goes up to where? Good. So your range is from 0 to infinity. Okay? Now, what about the y-intercept? Well, the y-intercept, you can easily just go to your table, right? Your y-intercept is where your x equals 0. So that's 0, comma, 0.5. Yep. How's that? Is that pretty good? All right, good. So let's try the next one. And actually, you know what? I would like you guys to try this one. I'll put this into the calculator as well. All right. Yeah. You have to put parentheses around that whole entire exponent. So you would put 2 to the, and you see how in your exponent you have x plus 2? That's what gets parentheses. And the plus 3 goes outside of parentheses, because you're saying it's not included in the exponent. All right? Are we okay with this? Jacob, you good? All right. So I'm going to give you guys a few seconds to work a little bit ahead of me, and then I'll put up my answers. All right, so while you guys are doing that, I'm going to fill in a couple things here. All right, so this is, I believe, a growth because b equals 2. Now the domain and then your range should be 0, 7. Yes? How did I get 3? Because, what is your k?
Oh.
All right? So when I go to graph this, I need to go to y equals 3, right there. I need to draw my horizontal asymptote. Please remember to graph your asymptotes, all right? And then I have, I'm going to use negative 2, 4, negative 1, 5, 0, 7, 11. I'm just going to stop there. I can't. I'm not going to do 2 19s because it's too far off. There we go. And I know that this is going to just be close to the asymptote. There. Did you guys all get this? Good. And of course, right there, that's my y-intercept, right? Perfect. Any questions? Okay. So let's talk about the transformations. So basically, they're saying, write it in words. How did the graph move from this guy to that guy? Right? What extra things were added on there? Okay, we have the +4. What else? Yeah, the x minus 2. So what happens? Okay. And what? Right 2 and what, Mitchell?
Up 4.
4. Good. Perfect. So try 8, please. You guys try. All right, give me 1. I already heard it. What did you say, Alex? Reflect. Left 1. Good.
Down to.
And down 2. Super. Any questions? All right. Great. You guys are doing such a great job. Okay, so next page. Or no, we're still on the same page. Yeah. Sorry, next page for me. All right, so now we're going to talk about something called E. All right, and E is actually really cool because it's a famous irrational number. Okay, it is an actual number that we use instead of writing out the entire number because you can't, right? So here's an example of another really cool irrational number that you guys know by a symbol. Pi. Yeah, oh my goodness, wow. So, all right, well here's the thing though. Does pi ever stop? No, that's why it's irrational, right? But you can't sit there and write out every single one, right? Like one of those numbers, so you use pi. Well, E is the same way. And E stands for Euler's number, okay? And it's actually pretty cool because it's pronounced Euler, but it's spelled that way. It's almost like Euler. I know, but it's Euler. Okay? But it's Euler. Alright, so anyway, E is an irrational number. And E actually occurs like in real life a lot. But, you know, hopefully we can kind of talk about that or something. Which is approximately, here's the good news. Your calculator has E. All right. Let's go to our calculators. Put out of there. Oops. Here's E. Go to second, divide. That gives you E. Second, division sign. Hit enter. Yeah.
Wait, does it matter if it's capital or not? Like the capital E?
No, you're not doing alpha, you're doing second divide.
Oh no, but I could
What?
no.
Okay, so it's 2.718. We like to round it to 3 decimal places, okay? So we'll say approximately, oh no, 2.718. Okay? When you guys put E into your Y equals, normally you should probably use second ln because that gives you an E to the, okay? But it's not wrong if you did second divide. Alright? Show you both ways. Alright, so let's try graphing. Let's graph E. The thing is, guys, E follows the same rules as the other exponential functions, okay? Alright? So, when I look at y equals e to the x power, what is my horizontal asymptote? What's decay? Zero. There is no k written, so it's like plus 0. So it's the same thing, y equals 0. Now, is this a growth or is it a decay? What is the base that this exponent is attached to? E. And tell me, E is approximately what number?
133.
So it's 2.718, and that number is greater than 1, so this has to be what? A growth. E is always growth. And that's because E equals E, right? So I'm actually going to draw my horizontal asymptote right now. If I can see it. Domain, same, right? Always, all real numbers, right? Just because it's E, don't let it mess you up. It's still the same rules as an exponential function. Where'd that come from? Outside?
The hallway.
All right, so the range and the y-intercept. So let's put this into the calculator. I'm going to go to y equals. I'm going to put in e to the x power. So you can say second ln. ln is right here under log. See that? Second ln. Yeah? And then that gives you an e to the, and it opens up the parentheses for you. So in the exponent, you only have x. So hit x and then close your parentheses. Yes? Okay, now let's go to graph. Let's take a look at it. Let's make sure that the right arm is going up. So this is a growth. Now I'm going to hit second graph. And there are my points. Remember, e is an irrational number. That's why you don't have a lot of really pretty numbers here, right? Might have one. Okay, so some points then. 0, 1. I'm going to use negative 1.37, negative 2.14, 1, 2.72, and 2, 7.39. Okay? And then let's just graph that. All right? And I just got those points straight from the calculator. Yeah? All right, so negative 2.14, well, that's just really close, right? Right there. Negative 1.3, I mean, it's not that much further. 0, 1. 2.7, there. 1, 2, 7.1, 2, 3, 4, 5, 6, 7.39. Right there. Yeah? I just want to make sure that you guys have the general shape and just a couple of, nicer-ish points. So then, guys, what is the range for this? Where does my graph start? Good. 0 to infinity. 0 to infinity. Good. Now, what is the y-intercept? Good. 0, 1. Perfect. Questions? All right. So the next one, you have a 2 in front, right? So make sure you type that 2 in first in your calculator, and then you do e to the x. Do you have anything else in your exponent? No, so close your parentheses there. Then what's your k? Minus 3. All right, let's graph this, fill in, and then I'll put up my answer. All right, so your horizontal asymptote should be y equals negative 3. Now, is this a growth or a decay? Question for you, what is the base?
2. The base is 2.
E. Be careful. The base is E because that is what the exponent is attached to. 2 is just multiplying e to the x, okay? All right, so this is a growth because your base is e. Now, as far as the domain, always, all real numbers. Your range, you should have had -3 to infinity. And then your y-intercept is 0, -1. Yes? Okay? Did you graph it though? I didn't graph it yet. You guys are all turning your page. But I hope everyone graphed this. Just graph it real quick. 0, -1, -2, 2.7, and 1, 2. Okay, so you're about that much. There we go. Yes? Okay. Good. All right, so now we're on to the fun stuff on the back. Okay, so we have this long problem. All right, first off, tell me, what is the horizontal asymptote? Y equals -3. Good. Now, is this a growth or is it a decay? Why is it a decay? Okay, well then first off, guys, what is the base that this exponent is attached to? 2. Right? So then that's a growth. 2 is greater than 1. Right? Right? So Mitchell, are you back in? You said you were out. Are you back in?
No. Yeah.
So now domain. -infinity to infinity because all of my exponentials, right? Okay, so well then now let's graph. Right? -3 where my asymptote goes. Now, let's put this into the calculator. Guys, you have to be careful when you put these into the calculator. You got to make sure that they look just like the problem. -2? Yeah. Anyone else like a highlighter? Alright. So -2 and then parentheses 2. Oh no. 2 to the, and that x plus 1 in your exponent, that also needs to go in parentheses. And then -3. Yes? That's how your graph should look. Okay. So there are my points. Now let's copy them over. Make a little table. So I have -3, -3.5. 1, 2, 3, 1, 2, 3.5 right there. -2, -4. -1, -5. 0, -7. 1, -11. Yes? Alright. So guys, what is my range here? My graph is starting where? Yeah, which is -infinity all the way to, where does it get stopped? -3 at the asymptote. Good. Now, where is my y-intercept? Huh? 0 what? No. Check your second graph. Check your table. Second graph. Should be 0, -7. All right. Okay. Right? 0, -7. Okay, so now your increasing and decreasing interval. Alright? So first of all, your increasing and decreasing intervals are always your x values, right? So for these, let's just make a little note here. It's always going to be same as your domain. Alright? Because it's your x values. Okay? So now, remember, starting from the left, what is this graph doing? Well, what is it doing? Is it increasing or is it decreasing? It is decreasing. Yeah, that's going down from the left. So it's decreasing all the way from negative infinity to positive infinity. And then your increasing interval is none, because there is no point on this graph where it increases. Alright, so as x approaches negative infinity, yeah? Well, which arm am I talking about here? Like, these are the end behaviors, right? If you're on the x-axis and you want to go towards negative infinity, which arm am I talking about? Left or right? Left. Good. So look at your left arm. This left arm, is it going straight up to positive infinity? No. Is it going straight down to negative infinity?
No.
It's actually stuck, right? It's stuck at the asymptote, which is at where? Where's your asymptote? -3. Okay? Now look at this one. As x approaches infinity, then which arm is this? The right arm. Well, then look at your right arm. Oh, no. Look at your right arm. What is the right arm doing? Going down to what? Negative infinity. Alright? So for these exponentials, they're not going to be doing the same, they're not headed in the same direction. Alright? So just make sure you take the time to look at both of the end behaviors and see where they're going. Alright, questions about this? You guys are doing such a good job. Listen, you guys try this one. Okay.
Oh, well, technically, I skipped to the third one,
Why?
but I finished the third one now.
Alright, well what happened to this one? So, example 12, what'd you get for the horizontal asymptote? Okay. Now, is this a growth or a decay? Good. Because? Good. Now your domain? Alright. And then your range?
Our range is -0 to -3.
Oh, no. No,
Yeah,
0 to
read it
infinity.
online.
Yeah,
Okay.
because it's 0. Alright. So, okay, let's see. Y equals 0. Alright. Now, when I go and plug this into the calculator, this is what I get from my points, right? -4, 9, -3, 3. -3, 3. What is this? -2, 1. 1. And what is 0? 0.11. It's all just really close, right? Alright, there we go. Okay, so Carlos, you said you had you were a little bit confused about the range, right?
Yeah.
Okay, so let's take a look here. When I'm down here at negative infinity, does my graph exist? What?
No.
Is my graph here? Is it down here where this pink line is?
No.
No. Is it down here?
No.
Is it at -3?
No.
-2? No, -1?
No.
No. Where does it start?
Zero.
At the 0. And then it keeps going up to where? Yeah. So 0 to infinity. Okay? So what is your y-intercept? 0.11, right? Now, is this graph increasing or decreasing?
Increasing.
Huh?
Increasing.
Increasing. Did you start from the left?
Decreasing.
It's decreasing. It's going down. So it's decreasing from negative infinity to infinity, and so it is not increasing anywhere. Okay. Go. All right, so now let's look at the end behaviors. Your left end behavior, where's that going? Infinity, good. And then your right end behavior, what's happening there? It's going straight, it's stuck at 0, good. Perfect. All right? Did any of you guys start the third one? All right, try the third one. So, horizontal asymptote, y equals -4. Yes?
Yes.
Growth or decay? Thank you. Because b equals e. Remember, you gotta look at the thing that the exponent is connected to, that base, right? Okay, so the domain, good. And your range should be -4 to infinity, yes? Your y-intercept is 0, -1. Yeah?
Yes.
Increasing interval from negative infinity to infinity. So there is no decreasing. So your left end behavior is at -4, your right end behavior is going up to infinity. And if I were to graph this, I would graph the asymptote first. 0, -1 right here. -2, -3.5. And then I can get like another point. What is that? 4.15. 1.15. There we go. All right. And that's it. Do you have any
Yay.
questions?
No.
You leave it there.
Okay.
Wait, leave it.
I'm going to leave it.
Subscribe.